Okay, in this video, I will be explaining what the chain rule is. Basically, the chain rule is one of the most important rules in calculus because, as you know, in calculus, you take the derivative of almost everything. So the chain rule makes it easier for us to take the derivative of composite functions. And in the textbook, it is defined as follows. If G is differentiable at x and f is differentiable at g of x, the composite function capital F equals f composed of g, defined by capital F of x equals f of g of x, is differentiable at x, and f prime if capital F prime is given by the product capital F prime x equals f prime times gx times g prime of x. In Leibniz notation, it is described as dy over dx equals dy over du times du over dx. So this is just taking the derivative of what's inside the function, which is supposed to be another function. But instead of explaining it and making it more confusing, I'll just give you an example. So let's take f of x, capital F of x equals the square root of x squared plus 1. Now, the radical indicates a function, and the inside is the other function. Therefore, this is f of u and this is g of x. So let's put it into paper. F of u is square root of x, simply because x just means the function inside. It just represents the thing inside. And g of x equals x squared plus 1. And now we have to take, of course, the derivative. F prime of u and g prime of x. And we take the derivative, which is x negative half, and brings it down. Okay, and this one is simply 2x. So now for the fun stuff. Let's see. Capital F prime equals, you take the derivative of f, multiply it by g, or the stuff inside it, the stuff inside the original function. I'll show you in a second what I mean. And then you multiply it by g prime of x. And then you put the derivative of f of u, which is negative 1 over 2, and inside where x is, you put the original g of x, which is x squared plus 1. Now you multiply that by 2x, which gives you, well, here you cross out the 2's, you are left with x over the square root of x squared plus 1, and you leave it like that. And now we can do another example. Okay, let's take a longer function. Okay, let's see this. Okay, capital F of x equals, x to the fourth plus 3x squared minus 2 to the fifth. Here, the to the fifth is the function outside, and the stuff inside is g of x. So now you take f of u and g of x, and of course you already know what comes next. You take x to the fifth, because x represents the function here, the inside function, and this one is x to the fourth plus 3x squared minus 2, and the derivative of both. I'm sorry for the sloppiness, I'm not used to writing with this. And 5x to the fourth and x of 4, I'm sorry, that's not it, 4x to the third plus 6x. Check my time frame, I'm sorry about this. Okay, I still have time. And then make some space. You take, of course you've seen this before, capital F prime of x equals 5. Then you put the stuff inside, the fun stuff, 4x to the fourth plus 3x squared minus 2 to the fourth. And then you will multiply it by 4x to the third plus 6x. This is kind of hard to compute, so you can just leave it like that. I mean, I don't think I'll have enough time to, or maybe I will, I don't know. But let's just leave it at that. And I'll show you another example. Example number 3. Y equals the cube root of 1 plus 4x. This one's easy, fairly easy. It's perfect to end this video. Might go a little over my time, but it's fine, I guess. So f of u equals the cube root of x. And g of x, simply the stuff inside, 1 plus 4x. And you take the derivative, so x is 1, and this is the derivative, and this is the derivative of g of x, simply 4. And now you put it together, y prime, which equals 1 over 3, 1 plus 4x times 4. And your answer is 4. Actually, yeah, it is -1. It's a negative here. Sorry. 3 square root of 1 plus 4x. And that's your answer. Well, this was the whole presentation on the rule, and perfect, just on time. Okay, so that's the chain rule.